rate functions. It is calculator active all the time, except for the next 10 minutes. Okay, so let's clean up, put away the things. Homework's in the middle of the table. So here's the situation. You've got a function, a of t, which just indicates the amount. You've got a function r of t that tells you the rate that things are being added. You've got s of t, which is the rate that things are being removed. If you need a context for this, think about like the swimming pool problem that we did. Right, water's getting pumped out, water's getting pumped in, pumped out, sorry. Or it's a sand pile, whatever context you need, fine. But A is your amount, R is being added, S is being removed. Based on that, you have 10 minutes to figure out the next 7. I'm looking for setups and answers. There are no numbers you can give me. Feel free to use your survival guide. Feel free to get help from a peer. Anybody that needs a kickstart here, this top function is R of t. They added or removed? Be careful. Added. S of t, which is this little segment over here, is the rate that you're being removed. A of 0 equals 500. That's your initial condition. So initially you have 500, whatever the things might be. The value of A of t at any time t. Well, A of t, I know I start with 500. Then what else? I start with 500 things, 500 pounds, 500 yards, 500 whatever. What else is happening in the situation? Oh my. Adriana, what else is happening in the situation?
You're adding stuff at a rate of R.
I'm adding stuff at a rate of R of t. So if R of t is the rate that I'm adding stuff, and A of t is supposed to be how much stuff, then it's going to be 500 plus the integral from 0 to t, not A, but R. R of t dt. What about S of t? Jennifer, what about S of t?
You don't use it because you're only going from 0 to 5.
Say that one more time.
You don't use SAT yet because you're only going from 0 to 5.
Right, if I'm only on the time interval 0 to 5, I'm not actually removing anything yet. And we've seen that in some of the problems where like you're putting water into the pool for a while and then later you spring a hole. Right, you're paying attention to your domain restrictions here. Now, I bet there's somebody in the room that realizes that my answer is good, not great. I want great though. My answer to number 1 is good, but not good enough. No, Amy, why is it not good enough?
Because you have T up there and then T is your variable.
Right, I don't want to use T as the limit of integration, but I need to because A is a function of T. I need to use T as the limit of integration. I shouldn't be using T over here, so change it to something else. And if I'm named Jose, I am probably going to change it to R of J DJ. Okay? The rest of them keep going. We'll check in a little bit.
Oh, yeah.
What you guys are?
Plus how much you add, but A is not the amount that you're right, that's what R is. A is how much you actually have. R is how fast you're putting in. And S is how fast you're taking out. That means something way different. Friends over here. It's the last value well, right? So you don't necessarily know you're going all the way to 14. So you're just going to say minus the integral from 5 to t with 2. What about the notation?
What would be the height of it?
R is how fast you add it. So the integral will be how much plus how much. Which is why when I did it, I started at 500. That's your initial. This much plus how much did I add minus how much. So it's not going to be 5 to 14. The idea is that T could be anything between 5 and 14. It is. Imagine if I said it's 10. How would you figure out how much line there is? If I said how much is in there times T equals 10, you get to figure out how much you have to spend. Plus how much you add. Now that's what you're going to experience. That's why you need to do the integral from 0 to 10. That's R is how fast you're adding.
It's the minimum.
So,
No.
not 5.
I think it's what we have to.
Wait,
Yeah,
R.
yeah, goal.
So you're going to do the 500 in the beginning. 500 plus the integral, because the integral is going to represent how much you have added from the beginning, which is times 0, up until that value is 2. So 500 plus the integral from Once you know that T is some number between 5 and 14, that means you've actually reached the point in the day of whatever it is. Where you're actually start moving.
I know, but I'm.
That's why I have the domain restricted. But now that the beginning is at 5 to 14, I must.
So it's 1.5. Did everybody get a chance to see current grades?
What's the problem?
What's a crop?
Yeah.
I made it up.
Oh, okay, so it's not a real.
A crop is not actually a real thing.
I thought it was like Ross. I was just add them all.
But since it's 1 times 2, just binder.
Two times. And she's like, it's 3 times.
All right, friends, let's look at a couple of these real quick, and then time to split. All right, number 1, we already talked about that. Number 2, because the t value is between 5 and 14, that means that we've made it far enough into the problem that I'm like out here. I'm adding and I'm taking stuff out at the same time. So your integral has to be 500, the amount in the beginning, plus however much you would have added. You're doing an integral from 0 to tr of whatever, minus your integral of s of whatever, but you have to start at 5 and go all the way to t. Right? I deliberately built in that domain restriction that we only start removing things at like the 5th hour or the 5th, I think it's flop in this problem.
Flop.
I kind of feel like I'm flopping right now, but okay. All right, number 3, we seem to be much more successful. We're going to do 4 trapezoids, equal width, going from 6 to 14. Width of each trapezoid? 2. And so the area of a trapezoid, 1/2, base 1, base 2 times height, because this is one of those really kind problems where they told you the bases, the widths are the same. You can do 1/2 and then it's s of 6. David, I think on your paper and some other papers I saw just the 6. It's not 6, it's the value of the function at 6. Plus s of 8 twice, s of 10 twice, s of 12 twice, s of 14 once. But this only happens when the widths are the same. You use the first one time, you use the last one time, and all the ones in between twice. Times 2 because it's 1/2 sum of the bases times the height.
It's 2 times S. No, 2 times S. I thought it was 2 times 2, but then I forgot. It's S.
All right, number 4. If A of t is increasing, well, we've got 2 things going on. We've got R of t, which is how fast stuff is being added. S of t is how fast things are being removed. A of t goes up if what happens? What has to happen? If A of t is going to increase, R of t has to be greater than S of t. So look at the graph. Where is R of t greater than S of t? And this is the only reason I gave you guys the graph. In the beginning, from 0 to 5, R of t is the only function in town. Right? The only thing that's happening is you're adding stuff in. So I'm increasing from 0 to 5. Wait, 0 to 5? Yeah, 0 to 5. And then I'm increasing from the intersection point all the way to 14. Way back in the day, we used to draw like those vertical lines to partition the graph up a little bit. And you'd say, oh, I'm increasing, I'm decreasing, I'm increasing. Great. Number 5, real quick. If R is crops per flop, Jose did not like the fact that I'm making up words. I was watching Buck Rogers,
Who's that?
a football player.
Oh, no wonder I didn't.
No, it's a futuristic kind of thing from the 80s, so old school in the future. Fun. And they had crops. They were measuring things in crops per flop, and I was like, yes, crops per flop! R prime, your derivative then, is a measuring your change in crops per flop, or crops per flop squared. How many guys said crops per flop? Okay. All right, if R is measured in crops per flop, R is telling you how fast you're adding, then the integral from 0 to 6 of R of t dt is the total increase, right? R is how fast you're increasing. Integral just means total. Total increase from 0 to 6 measured in crops. Jose really doesn't like the fact that I'm making up words. Number 7, if you're going to do the integral, 1 over 6 times the integral from 0 to 6 R of t dt, the reason for that 1/6 in front, the 1/6 is there for one reason only.
The average.
It's the average. So I would say it's the average rate of increase, because R is measuring increase from t equals 0 to t equals 6, measured in crops per flop. Jennifer, I swear we did not start speaking a second language since you were gone. All right, time to switch the groups. If you are in the thrilled with the 3, I need you over here in these 3 groups with your calculator. Fighting for a 5, you're going to be over here with your calculator, working on the same problem, just not getting the support.
No, it's like.
I was like, bro, I had never
Oh, did you see my calculator now, bro? I can't hold my calculator.
Right?
Flip it to the right.
I understand Lance is approaching the end of his useful life, so nice. And Juan, you're pretty comfortable on your calculator, right?
I'm comfortable. Someone touched mine.
It's not yellow, bro.
All the stuff that you do in there is going to project up here. You don't have to be back there, though. Okay? All right. Oh, whether you're in the thrilled with the 3 or fighting for a 5, I need everybody to look at the model problem. I need you to read through this, work it up, set your calculator up, all the things you're going to do on Thursday. Am I going to be sitting there? Nope. You can sit there if you like. You're the co-pilot. You can sit anywhere you want. And it's going to work this time. means that the bulbs are getting ready to die. That's cool. No, that's actually not. But, oh, I know what's going on. It's not just.
No, that's gonna help.
Okay, we are reading and entering stuff into the calculator, not looking at a blank piece of paper. Okay, Juan, is that what your screen looks like right now?
Yeah.
Perfect. So you keep going. I don't know why it's taking me so long to think about just using the cradle to turn my calculator into a remote control. Much smarter. Get the functions graphed, make sure you know what you're looking at. Get those units going. All right, we get the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant. That's G of T. And T is being measured from 0 to 8. Juan, I love it. You've already set up your window so that we're only going to look from 0 to 8. Beginning of the workday, we have 500 tons of unprocessed gravel. During the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. So, real quick, G prime of 5. How are we going to get G prime of 5, Edgar?
We go to the calculator,
Go to the calculator.
and then we press menu and then calculate.
Yep.
And then it says the first one, numerical derivative.
Numerical derivative.
And for x, we put 5.
But for leave X.
Oh yeah.
For the value, it's 5.
And then
Hit OK.
and you put 1.
F1 of X.
And enter.
And we hit enter, and hopefully all the friends, negative 24.587, all the friends over here on the side of the room, are we okay? Now, do I think every single one of you knows how to take the derivative of that function? Yes. Yes. The derivative of 90 plus 45 cosine of stuff shouldn't be too bad, but what a waste of time. Okay? Now, I want the explanation. What does this actually mean? Barry, you want to give it a shot?
The rate at which the gravel is falling.
There's parts in there that I like and parts that I don't like. Juan, can you go back to the graph for a second? I want to mark up the screen like we used to. On your x-axis, we're measuring time, right? In hours, and G of T is, this is a rate. And we're measuring in, what are we measuring in?
Tons per hour.
Should be tons per hour. So if G is measured in tons per hour, G prime is getting measured in something else. Your explanation of this rate has to start off with, at what time are we talking about? At t equals 5. What's happening at t equals 5? G is a rate function, right? So tell me about the function. The rate at which gravel is what? Gravel is arriving? What's happening to that?
Decreasing.
It decreases, be specific,
At a rate of
decreases at a rate of
24.
24.587, and if we're going to blow it anywhere, here it comes. We're measuring the derivative. We're measuring slope, which is a measure of how the y value changes compared to how the x value changes. So the units, one more time, David.
Tons per hour squared.
It's going to be tons per hour squared. We're measuring how the y value changes divided by how the x value changes. So tons per hour or tons per hour squared. What I would expect from everybody is that this first part, getting the numbers, the easy part. The explanation, there's a lot of ways to go wrong with this one. All the friends okay? All right, keep going with part B. Total amount of unprocessed gravel that arrives at the plant during the hours of operation on the workday. Over here, we get the answer and the
Is that or is that 500?
answer and explanation.
500 times 10. Yeah, so it'll be 1,325. How much?
1,325. Let's see what Juan gets. Okay, so Juan's got 1,325. How many guys agree with 1,325? Anybody want to disagree with the 1,325? Or am I the only one that wants to disagree? Where did the 500 come from? What a great question. Daisy, do you want to disagree?
No, I was going to say where the 500 came
Okay, where'd the 500 come from?
from. The problem says that T equals 0, the plant has 500 tons.
At T equals 0, the plant already has 500 tons. Go back and read the question one more time.
It only asks for how much was processed.
It asks for what?
How the total amount that arrived.
How much arrived during the workday? So Jasmine, what's your plan here? Juan, are you okay that we're just going to do the integral but not the 500? And no surprise, 825.551. And everybody's good? David? Okay, David, do we round here or not? Why not?
Because if they don't take it around, you only
They don't tell you to round, so you don't round. Yeah, Mariah.
Wait, so like even if there's like a question with, I don't know, like people or something?
People! Yes.
Like we round people?
You don't round until the College Board says to round.
Okay, so like even, like they're not gonna trick us with people?
They're not going to trick you with people. They will find other ways to trick you. For those of you that need to think about it this way, 825.556 people, what are they talking about? They're talking about zombie apocalypse times. Okay, 825 and like a half of a zombie left over. That's what we're talking about. Okay, you're out in the water.
You don't add 500.
You do not add the 500, Rombeer. Why are we not going to add the 500?
Because it's.
Why are we not going to add the 500? We just had this conversation.
Oh, that's unprocessed. That's
Because that's not why. Why, David, help him out. Why are we not adding the 500?
the question is asking how many process that arrived.
Arrived.
Oh, yeah, that's
They already had the 500, so don't fall for it.
Wait,
Yeah.
couldn't we have just subtracted 500 from the,
But Juan chose to do it differently.
oh, okay.
Okay? Now here's what I know for sure. If you have this expression, the integral from 0 to 8 g of t dt, you're going to get a point. But you're only going to get this point if you have it correct, accurate to 3 decimal places, and you don't round. For the people that had 500 plus, you're probably going to be given this point because they're going to be kind. All right, part C. This one should go well. Part C, using correct units. Explain the meaning of the integral from 1 to 6, 2 of 8, integral from 2 to 8, g of t dt. Then, using 3 trapezoids of equal width, approximate that value.
Average I know I think the one says like average weight. Average what?
On
It's
average.
So Daisy, are you back to that place where you're chopping up the interval? Good idea.
On average.
Okay, 2 to 8, and so the width is 8 minus 2 divided by 3, which is 2, 2, 4, 6, and 8. I'm going to have that 1/6 in front. Because these are trapezoids of equal width, you get to use the shortcut. So the shortcut says it's a half, and then g of 2, and then g of 4 twice, and then g of 6 twice, and then g of 8 once.
Oh, I know.
So the 6th, because there's a 6 there, 1/2 the sum of all your bases, but don't make the mistake I almost made. Oh, I did. Oh, I did. David, I think David sees it. I think Jennifer's about to see it. David, what did I forget?
So that comes from subtracting the interval by the modulus squared.
Right. It's 1/2 the sum of the bases times the height.
Oh.
Right, that's that constant width that Daisy found by doing 8 minus 2 divided by 3. You've got to make sure that you're multiplying by the 2. So 1, you've got 6, you're almost there. Don't worry, no one's watching. Just me. Okay, apparently the whole world's watching.
You're famous. She got used to it.
1, you just tell me when you're ready, okay? Because the nice thing with the calculator, I can just pass on to somebody else.
Yeah, you got
Like,
it.
like Abraham kind of looks like he wants some extra attention coming his way. And there's 12 other people that should be doing the same calculations, not just waiting for one to do the heavy lifting for you.
Put it all in there.
You messed it up? Oh, just put up. Enter.
Jose, pretty much the way I wrote it on the board is what you type into your calculator. That's what you type into your calculator. Except you don't have G,
You got that.
you have F1. All right, my friend over here. Okay, I'm going to get rid of this parentheses. I think that's get a little too many parentheses.
Yeah.
2 times F1 6. 2 times Apparently it does. There's F1.
2 times
Oh no, 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 no. Okay.
For D, is it asking about the first one or the second one?
This is another one. The 100 tons per hour. The atomic plant processing
Okay.
it. Yeah.
I'm not sure why, but when you type these in, okay, it's gonna work. Okay.
46.997.
What do you think it is?
46.997.
No, I don't agree with 46.9972. Okay, Juan and his calculator are having some issues. What'd you get? 90.637. I don't know that I agree with that either. 93.660. 93.660 or 93.661. Now, if you're Juan whose calculator hates him apparently, we're just going to deal with it or we're going to move on. Now I need the explanation. Take 30 seconds on your own. Write the explanation. Even if you come up with the wrong number, I care about your ability to get me the explanation. It's a very, very specific explanation that I need.
The average rate at which it increases,
not
right?
more.
The average rate.
Faster. They are processing 100 tons per hour and it's arriving at less than 100 tons per hour. So the amount of unprocessed gravel.
Yeah, T equals 5 the rate at which.
No, because we're just comparing rates.
No, that's just rate.
Which one's
We have
going
the
faster? They're
1.6
processing faster. It's coming in.
Is it average rate?
Right, that 1/6 is going to be an average.
On average.
Noemi, how do you feel about your explanation here? Okay, Noemi, you get the floor. What's your explanation? All side conversations need to end.
From t equals 2 seconds to t equals 8 seconds, the average rate at which the gravel is arriving increases at a rate of 93.661 tons per hour squared.
Okay. What I heard you say is from t equals 2 seconds to t equals 8 seconds, the average rate that gravel arrives is increasing at a rate of 93.661 tons per hour squared. There's some stuff in there that I don't like, and I'm wondering if anybody heard some of the stuff. Jasmine, what's some of the stuff? Okay, first of all, yeah, what you said seconds, we're measuring in hours. So from t equals 2 hours to t equals 8 hours, that was one of the things. Jennifer, what did you hear?
When she said tons per hour squared.
When it comes to this average idea, whenever we're dealing with like an average of a function, whatever the units are here, those are the units for the average. So what I'd want to hear is from t equals 2 to t equals 8 hours. You got the average part. But the average rate at which the gravel arrives, it's not increasing, it's not decreasing. The average is 93.661 tons per hour. Do you want to say that one more time?
Yes.
Okay. From t equals 2 to t equals 8 hours, the average rate that gravel arrives is, it's not increasing or decreasing, the average just is 93.661 tons per hour. Okay. All right, part D. Part D, the question is the amount of unprocessed gravel increasing or decreasing at t equals 5 hours? Normally, if they're asking you is the amount increasing or decreasing, you normally are comparing two different rates. You've got rate that water comes into the pool and rate that water leaves the pool. Or it was the amusement park and it was the rate that people were coming to the park and the rate that people are leaving. So far, we've only seen one rate. There is a second rate function hidden in this problem. I'll give you seconds to go back and read. There is another rate in here. Edgar, hold on just 1 second. David, what's the other rate? The 100 tons per hour. That's how fast like they're processing, they're working through. So if I want to make a decision, is the amount of unprocessed gravel increasing or decreasing? Have to compare the two rates. So one of those rates is like the arrival rate, and that's G of 5, and then you've got like the processing rate. And what's the processing rate?
Can we call it something else?
Wait, what's the rate that they're processing the gravel?
100 tons, but it's constant.
100 tons per hour. It doesn't change. It is a constant 100 tons per hour. G of 5 is going to be whatever that rate happens to be. And Juan, I know that your calculator loves you enough, so we can do this.
You have to find the candidate.
Yes, it does. I have faith. I have faith. G of 5. What's G of 5?
Alright, you always use it in
Oh, we
points,
will
yeah.
come there. No, we didn't. Oh, yeah.
My computer timed out.
It's from 1 to 100. In what way?
All right, Jose, this one's coming to you. Okay, so what's happening to the amount of unprocessed gravel? Increasing or decreasing?
It's decreasing
It's
at 5.
at T equals 5? At T equals 5, amount of unprocessed gravel, what did you say is happening?
It's decreasing
Is decreasing. Why?
because 100 is greater than 98.
Because 100 is greater than G of 5. I'm processing it faster than it's coming. I'm getting ahead. I'm getting caught up. Done. All right. Part E. You knew it had to come eventually. To the nearest ton, determine the maximum amount of unprocessed gravel at the plant during the hours of operation. To the nearest ton, determine the maximum amount of unprocessed gravel. What's the plan? What's the plan? Oh, so tired. Mariah, what's your plan here? No plan. Juan, what's the plan here?
Both functions?
Okay, so at t equals 0, okay, so over here we've got time and over here we've got amount. How much do we have at time 0? 500. Then I also heard you say that t equals 8 is going to be important to you. Well, how much at t equals 8? If I want to know total, how much do I have? It's first my 500
Plus the integral
plus my integral
from 5 to 8. 0 to 8.
from 0 to 8 of g of t dt. Don't stop there. Minus what?
100.
Minus 100. That 100 represents the rate that you're processing the gravel. It's not just going to be minus 100. Jennifer, what are we going to do? Right, you're going to do an integral from 0 to 8 of 100 dt. Just like g is a rate function, it tells you how fast, that 100 is telling you how fast. David, what else? No, because it's a constant rate of 100. The other thing you could do is if I'm processing gravel at a constant rate of 100 tons per hour for 8 hours, how many tons of gravel?
800.
800. The integral from 0 to 8 of 100 is going to be 800. Sadly, the thing that we didn't get a chance to do is look at the candidate. The way that you'd find the candidate for if you guys made it over here, you would graph the function like 100, find the intersection point, and the intersection point is the candidate. Tonight's homework is to do all the multiple choice questions. Those should be quick and easy. They're all calculator active. And the first, only the first free response question, that's due tomorrow. For the folks that are staying for the 2-a-day,
Multiple choice and the first one?
the homework is what we're going to do.
What if we can't today?
Then you have the homework, which is to do all the multiple choice and the first free response.